All right, we are recording. So once again, welcome everybody to the Trees Around the Globe Student Research Campaign webinar. This is the second webinar in a series of webinars. And as you know, what we like to do with these webinars is to be very informal. So we'll have a presenter talking to you about how they research trees in their environment, how the science that they do is related to how it's related to trees, how it can be tied into our Trees Around the Globe campaign. When I say informal, because after the presentation's over, we will have a question and answer where I will unmute you or you can unmute mute yourself. Right now I have it that you can't unmute yourself. Sorry about that, but I'll do that in a second. But so you can talk to the presenter and me about what you want to do with the campaign, how your measurements are coming, how you can start taking measurements, and we'll go from there. So, or how you can continue taking measurements. So what I'm going to do first is I'm going to share my screen. I'm going to talk to you a little bit about the ICESat-2 mission, the Ice Cloud and Land Elevation Satellite 2, just so you get a feel for why we do it like this. So I'm going to hit slideshow, okay, and let me do this a second here. All right. We're going to go ahead and get started with this. So, could you tell me what you're seeing? Could you type in the chat box what you're seeing? Are you seeing the presenter mode, or are you seeing two slides, or are you seeing one slide? Two, okay, got it. So I just have to switch it because I have two screens up here. So it's strange because this is a new laptop I got literally last week. So we are going to start it from here. We're going to swap displays. And there we go. You should have on your screen just a single slide. If you don't, well, we'll work on it from here. But once again, Trees Around the Globe Student Research Campaign, webinar number 2. And this is going to be focusing on something called Collect Earth. And that's with Peder Nelson. He is my co-lead for this Trees Around the Globe campaign, student research campaign. And he'll be talking to you about how to look at global forests, global canopies, trees, using the Collect Earth program. And then he has some other added attractions that are going to be really cool. But first, I want to talk to you a little bit about why we are aligning this campaign to a satellite mission. So this is the ICESat-2 satellite. It stands for Ice, Cloud, and Land Elevation Satellite 2. And it was launched on Saturday, September 15th at 6:02 a.m. Pacific time from Vandenberg Air Force Base in California. So what this satellite does is this satellite is traveling through space now, and it's sending laser pulses to the planet. And it's calculating the time it takes the laser pulses to leave the satellite, which is about 310 miles above the Earth's surface, sends these laser pulses out of the satellite, they hit the Earth's surface, and then bounce back to the satellite. And we are calculating the time it takes for those laser photons to travel that distance. And then we're going to go repeatedly over a certain area. We're going to go over the planet repeatedly, and we're going to look for change. So we're going to look to see if the time changes at every location on the planet, the time changes that laser photon, those photons took to leave the satellite, hit the Earth's surface, and back again. So we're going to monitor that change over time. So we'll be able to look for the height of everything on our planet, from ice sheets to sea ice to trees, which is why we're aligning to this. The satellite will be able to measure tree height, and it's been doing it's up in space taking measurements now. The data isn't publicly available yet, but it'll be available very soon. So stay tuned for that. All right. Now, we're going to show you a quick video here about how the satellite, or basically why the satellite is here, and what measurements it takes, and why it's so important that we have this satellite.
From satellite data, we have a very good handle of how our Earth looks like. We can see oceans, we can see the sea ice, we can see our forest. What is much, much harder to measure is how high things are on a global scale, almost impossible.
Let me pop this up. So I'm not sure what happened there. Sorry about that. That was strange. Now, can you see it? Give me a thumbs up if you can see PowerPoint. All right, cool. Not sure what happened there, but all right, sorry about that. Here we go. So here is the video showing you why we need ICET2 and what it measures.
From satellite data, we have a very good handle of how our Earth looks like. We can see oceans, we can see the sea ice, we can see our forest. What is much, much harder to measure is on a global scale, almost impossible.
ICET2 adds the third dimension, the elevation. Repeating measurements from ICET2 will allow us to measure changes in the ice sheets or in the ocean or in land.
ICET2 is designed to measure the changes that are going on in the cryosphere, in the polar regions.
All the change is at the edges. Those are the steeply sloping parts of the glacier that interact with the ocean, and that's where all the action is. That's where all the mass is being lost.
In order to estimate the mass changes, we need to know the height of things. The mission ICET2 carries a single instrument. It's called ATLAS, the Advanced Topographic Laser Altimeter System.
ATLAS sends out small pulses of laser light 10,000 times a second. And by measuring precisely how long it takes that light to go from the spacecraft down to the Earth and back up to the spacecraft, allows us to figure out what the height of the surface is beneath ICET2.
We need to measure the time of flight of a single photon or a single laser pulse with a precision of a billionth of a second.
NASA engineers had to come up with entirely new ways of measuring time very precisely.
A billionth of a second translates to an elevation change precision of just a few centimeters. Climate change is amplified in the polar regions. ICET2 is designed to measure those areas and will help us to understand what's going on with our planet.
All right, so what the satellite does is it travels around the planet. And as it travels around the planet, it's taking these measurements. So it has what's called a 91-day repeat orbit. So it hits the exact same spot on the planet every 91 days. And in every 91 days, it has 1,387 orbits.
1,387 different orbit paths every 91 days by ICET2. The orbit pattern creates a dense grid over the poles, all anchored here at the Greenland Summit Observatory. Since each orbital path will repeat every 3 months, scientists will be able to observe ice changing between seasons. The more frequent measurements of the polar regions will give us a more detailed look at retreating glaciers, 1,387 different orbit paths every 91 days by ICET2. The orbit pattern creates a dense grid over the poles, all anchored here at the Greenland Summit Observatory. Since each orbital path will repeat every 3 months, scientists will be able to observe ice changing between seasons. The more frequent measurements of the polar regions will give us a more detailed look at retreating glaciers, melting ice sheets, and thinning sea ice, and the global impacts of those changes.
All right, so quickly, we have ICET2, and because we have ICET2, we actually had an ICET1, which is just called ICET. And what you're looking at here is representation of how the laser pulses are scanned onto the planet, meaning how far they're spaced apart versus ICET1 versus ICET2. So if you look here in the center, this is a size of a football field, and ICET1 took a measurement about every 170 meters, so basically at every end zone. And for those of you, this is American football here. And then also ICET2, you can see the green circles, that takes a measurement about every 70 centimeters. So you can see it's about every yard line on the football field. So what happens here is that we're going to get a lot more dense data, a lot denser data with ICET-2 than we did with ICET-1 because of how closely they're spaced together. It's going to be firing off 10,000 laser pulses per second. The original satellite was approximately 40 laser pulses per second, so it's a huge difference. We didn't have the technology back then to make something by, you know, by 100. You know, we didn't have the capacity to do 10,000 laser pulses per second back when we built ICET-1 in around 2001 and 2002, and then it launched in 2003. So it has a huge impact on how much data we get and how we can monitor the height of our planet. And one of those things that it's going to be measuring is our tree heights, and that's why we're aligning it to the campaign the way we are. So here we have our first measurement from ICET-2. This was on October 2nd of 2018, and this just shows you a track that it took. What you're looking at there, you're looking at the blue in the center graph. All the blue dots are photons, and that dot, the dots that are right through the middle, through that really thick, dense line, that is ICET-2 measurements, and that's showing you as it's moving the height measurement straight across the center of Antarctica. All those extra blue dots that are above and below that really dark line, those are the sun's photons. So, and then if you look on the bottom is that same image, but if you turn that image 90 degrees, you can see the height. So this is showing you the height. That wavy line in the middle is showing you the change in height that the satellite was getting as it fired its photons to the planet and then back again. So very cool. This was our first look into how the data was coming back from ICET-2. And this is the same type of data that you're going to find eventually when you look at the tree height data from ICET-2. So this is where we are. We are going to be looking at tree height. And tree height, you know, is the backbone of this campaign, of the Trees Around the Globe Student Research Campaign. But what happens here is that you're going to be able to take the data using the GLOBE protocol for tree height. And then once you get that data and the ICET-2 satellite data for tree height is available to the public, you'll be able to compare your data with the ICET-2 data. And when you compare that ICET-2 data to yours, you can help the ICET-2 team help to validate the satellite data. So it's cool. You're part of a NASA program. You're part of this larger ICET-2 measurement campaign. So this is good stuff, and you'll be able to take great measurements and be aligned to the ICET-2. We have scientists on our team, on our ICET-2 team, who will be looking at your data and comparing it also to the ICET-2 satellite data. So we're super excited about that. You have to wait a couple more months till actually the ICET-2 data is out there for public consumption, because we have to do a lot of testing of data to make sure the satellite's working perfectly well and that the data makes sense. So we have to do a lot of testing. We have a colleague who's going to Antarctica very soon, and she's going to be, doing some ground-based measurements and some reference points in Antarctica to make sure the satellite is working correctly with the measurements on the ground versus the satellite. So, stay tuned for all that. So here is showing you some of the tree height data that has come in. This is over just the last 30 days. So we have ones coming in from the United States, Croatia, the Ukraine, Oman, and Israel. And what you see here is what you get from the Advanced Data Access tool in Globe. This is showing you, and I highlighted some of the most important ones. This is the spreadsheet that you get when you want to download the data. So then you have, the school name, and I'm just going to say the ones in green, the latitude, longitude, elevation of your study site. And then you have when you measured the tree height, and then what the latitude and longitude was at the base of the tree, and then how tall the tree was. So very cool that these schools are starting to do it. I know a lot of schools just got in session over the last couple weeks. So, we're waiting for some other ways to do that. And yeah, as Kristen said in the comments, we're actually working on doing tree height for the NASA Globe Observer Citizen Science effort. So that'll be coming out in the near future. So stay tuned for that as well. All right. So our next campaign webinar will be on November 27th, and it'll be live from the Institute for Earth Observations from Palmyra Cove, New Jersey, with a program called Acquire, Analyze, and Apply. You can go to our website, the Globe website for the campaign, and look up at your look up in the webinar section the information about this. There's a nice write-up about, you know, who the presenters are and what they're going to present. So once again, we're really trying to focus on those people who are working and doing research in trees, in forests, and tree canopies and all that, and how they really observe trees in their environment. And by doing that, it can help you with research projects. There's people you can go to help, you know, say, hey, I have this information, I've taken the globe measurements, and this is how everything works. You know, this is how I use it in my research. You know, so we want to try to make it as, you know, informal as possible, make you feel comfortable with the viewers, make you feel comfortable with the presenters and everything. So you can go to some people and say, hey, I've got these measurements, I want to do a research project, and I like what you're doing, you know, with your research. You know, that would be great if I could do something like that. So that's what we're trying to do in this first part of the campaign for this first year. So what I'm going to do now, I'm going to stop sharing, and I'm going to introduce Peder Nelson from the Oregon State University, and he's going to talk to you about the Collect Earth tool that he's been using in his research with trees. So I will pass it over to Peder. And I should mention one thing. A lot of you during the presentation are asking for control of things, and sorry, but we can't do that because we have presenters who are presenting, and you know, we don't want to cause too many problems with the technology and stuff. You saw we already had technology glitches. So, you know, enjoy, and I will pass it over to Peder.
All right. Well, thank you very much, Brian. All hear me? Give me a thumbs up if you can hear me.
We got you, Peder.
I know I'm having some hiccups on my end of things, so hopefully my voice and everything will come through nice and clear here. I am going to kind of let me see, blow up my slides here, so you can see the whole area of expertise is really around geography questions specific to trees. I'll go into a little bit about who I am in a moment, but I just wanted to give you some ideas about the type of questions that I ask. In particular, things like, where are trees located? What type of trees are growing in a specific location? What is the size of the trees around in the area? And in particular, you know, I have questions around things like the carbon cycle, like how much photosynthesis is going on, and then how much of that, as the leaves change and fall off trees, or as a tree actually falls over and decomposes. All part of the carbon cycle. So as Brian mentioned, you know, for the next 3 years, we want you to be part of our observation team and really helping us to measure tree height, but also importantly, the land cover in your area. So how many trees are actually there? And we can watch that change over time. Also, of your area or the green down. When are the trees, or when are the leaves on trees coming out, or when are they falling off? Like here in Oregon right now, we're having a green down event where all of our deciduous trees, they're starting to lose their leaves at this time, and are starting to be part of that carbon cycle where they are now starting to decompose and turn into other materials. So these are a couple of the pieces that, although I'm going to talk about observing these things from space, these are the pieces that you can actually help us with on the ground. You can do even going inside. And is also one of the first steps for going out and recording your tree height. And that's looking at the aerial photos or the satellite images that are recording photosynthesis across the planet is in a certain location. So that's what I want to focus on. This is the type of research that I do. I spend a lot of time using a tool like Google Earth, as well as many of the other data sets that NASA provides, including things like ICESat, to map, measure, and monitor the Earth. So a little bit about me. So I am an instructor of geography and geospatial sciences in the College of Earth, Ocean, Atmospheric Sciences at Oregon State University in the United States. You can see I'm located almost halfway between the equator and the North Pole at 44.5 degrees north. So this latitude longitude is a really important way that I can work with you, locate trees around the world and put them onto a map or onto the globe. So that's a really important piece of skills that if you can learn how to locate things, we can allusion to that. Importantly, I'm also the science lead for the land cover protocol in the Globe Observer mobile app. So that is a nice tool that allows us to take pictures of the Earth and classify them. Oregon, where I'm located, we have types of forests, and most of the state is covered in different types of forests and types of trees. And so what I'm hoping is that over the next couple of years, you guys might be able to make a map similar to something like this, letting us know the trees you have around you. In Oregon, a needle leaf type of trees, conifer type of trees that keep their needles all year round. But we also have a lot of what we call deciduous trees, trees that have broad leaves to them, and that the leaves fall off at different times of the year, usually in relation to temperature or water availability. So these are two typical ways that we talk about the different types of trees that are out there. And you can see that we have a wide variety here in Oregon. So this will be an interesting thing that we can start comparing between different schools and different regions, is the different types of forests that are out there. All about just first locating where the heck are these trees around the world. Where do we find them, and are there any similarities between the locations where we find trees versus areas where we don't find any trees? I'd like to try a little video here of trees. So bear with me while I try to. All right. I don't have them embedded like Brian does.
The second largest country in Africa, DRC, the Democratic Republic of the Congo, so in 2003. Perhaps the only good thing to come of the civil wars are the country's vast, untouched forests for business. But what is returning to the DRC? And how can local communities take ownership of this, their home, and secure a better future?
DRC has not had any formal system of land tenure. I've been working with the African Wildlife Foundation, and we've been working with them to lend our spatial data expertise, remote sensing capabilities, analysis of satellite imagery to help them with their on-the-ground zoning activities, which they're formalizing with the government of the Democratic Republic of the Congo for land rights and for land use planning with local communities.
Spatial data expertise, remote sensing capabilities. What do these words mean exactly? For over 10 years, this satellite has been orbiting the Earth. It's called Landsat 7. It collects information about the Earth's surface, which people like Janet can then interpret.
So we can feed information derived from Landsat imagery into a variety of models planning in this landscape. And one way we've been using it is to identify the areas of highest conservation priority. So we've been working in the Marenga-Lapore-Wamba landscape, which I sometimes call MLW. It's in northern DRC. It's the size of South Carolina. And it's full of tropical moist forest. So using Landsat imagery, we were able to zoom in on this particular forested area, connecting two protected areas in the east central part of MLW landscape. And it's an important corridor for the migration of bonobos between the protected areas, as well as other terrestrial species.
Once the AWF identified this critical area for conservation, it began working with the government and local communities on mapping the region. The mapping process has a dual benefit of preserving biodiversity and helping local villagers to secure their own land use rights.
Oui, carte ezali likanisi moko ya malamu. Po carte ezali bo atake bana tango mususu bayebi esika lopango ebandi pe lopango esuki te. Me lukola sika wa grâce na zonage tango babimisi par exemple carte ya lopango oyo mwana akozala na facilité munene pona koyeba esika lopango ebandi pe lopango pe ekozala epa na ye doko soki bato baye akolakisa bango facilement sans pour autant que alobake tozalaka nde boye lopango na biso ebandaka nde boye lokola carte ezali document munene oyo ekede ata na génération ya future.
During the DRC war, it was their refuge, and still now the forest provides them with food, air, and shelter. With the help of Landsat imagery, this vital resource can be managed and preserved for the benefit of wildlife and generations to come.
Okay, so I want to give us a little bit of an idea why we might actually want to do that. And pause this so we don't go on to the next video. And I'd like to highlight is this that allows us all to work together to make some of these maps that are really important for us to keep track of where trees are located and where they're not. As was important piece of knowledge and information that help us make better decisions. So what I am going to show you for the next couple of minutes or so is hopefully, so my internet is noting that I do have some stability issues, so hopefully it will clear up here. What I'd like to show is this Collect Earth online tool. And what this allows us to do is actually start labeling places on Earth, whether there's trees or not. And you can go there on your own, as well as during this if you have the bandwidth. But if you go to this collect.earth website, you'll see that there is a variety of organizations that are using this. The GLOBE program is here towards the top. And this is where we will be having additional locations that we can use through the next 3 years. So you can see I started one this summer for the GLOBE Learning Expedition. So we're going to, we're going to just start looking at one of these locations. And so you can select this project, and what you see now is locations where we actually can start labeling whether there's trees or not. So I'm just going to click the go to the first one. And you'll notice I am not logged in or registered for this. So you don't have to register for this to make use of it. But you can see I need to zoom out a little and notice that I am looking at a satellite image, and I can zoom out. And one thing I'll note is that I appear to be looking at a forest. And the reason why I say that is because of these lines that I see inside of here. And so I can actually use my tool inside of here. I can select all of these trees or these points and label them as a tree. What this allows me to do is then count up the number of points here to identify how many trees I might have in this 100 meter by 100 meter area. So I can just click save, and it will save that information and then move me to the next plot and the next location. And what I am doing is much of what you have done inside of Google Earth. And so I can zoom out, and I'm looking for features that look like trees. So we can see these black marks here might be trees, but they may not be. And so this is where we need the on-the-ground information from people like you to help tell us whether or not we're seeing trees or not. In this case, none of my circles really fall on what look like, and I'm going to just highlight my points, and I'm going to label these as not trees, and save that and move on to the next location. So this is the type of science that I spend all my time doing, is going through and looking at satellite images like this and trying to see where am I located on Earth. So here's an example where one of my locations ended up out in the ocean where there are clearly no trees. So again, that makes this one really easy, right? Because I didn't find any trees. And save that. So this is essentially what I do as a scientist, and go through and look at as many points as I can and try to label them. And so one thing projects is how many, and where we could use your help. You know, please go onto this website and start going through some of those locations and labeling whether there's trees there or there aren't any trees. So really, that's where we can see where the trees are located around the world. And then on the back side, data set that we can analyze and we can look at and see what type of trees are located in that location. everybody else came in fine, and so I hope it's not too distracting. I will try to come back and do something to give a direct some directions to this, and I can send you the link to this really easily. I'll put this into the chat. And okay, for me on this end, I would like to turn this back over to Brian Campbell.
All right, thank you, Peter. And sorry about the technological and audio glitches we're having. It's a bandwidth issue with the Zoom platform, so we have to kind of grin and bear it for now. So does anybody have any specific questions about this? And I think you can hit the raise hand button if you have anything to say, or you can type it into the chat. This recording is going to be put up on the Globe webinar page, and that page is going to be right here. This is what it looks like. And this is the page that you're seeing here. This is the campaign page, the webinar page. It shows you the upcoming webinars as well as the archive webinars. And this webinar will be under the archive section after I get it back from Zoom. And once again, I apologize for any of those screen glitches, but kind of out of our control right now. So does anybody have any specific questions? You can put them in the chat, or I see a hand up. So Vaibhav, do you want to give your question? You should be, I'm going to unmute you. There you go. You have a question? There's a couple questions coming up in the chat. Okay, there's a question from back. Valerie mentioned there's a question from back for densitometers. What apps do you use? Do you have that answer, Peter?
So for densitometers, I do not have an app that I use related specifically, but I do not have one off the top of my head that we actually use. Sorry about that.
All good. And a couple other questions. Will the data we get from ICESat-2 have the tree column height like the one you showed us? I imagine the canopy height may vary. Yes, it's going to have the canopy height, so it's going to have just that canopy height, you know, off the top of the tree. So it may be able to see the column height, but not in very dense forests because it's a matter of the laser pulses going between the leaves or whatever, you know, to get that column height. So you may as very well see it depending upon the photons that get returned to the satellite. So can we access different data that's available on Collect Earth, Peter? Peter, you're on mute. Okay, one more time, Peter. So can we access the different data available on the Collect Earth website? Okay, Peter might be having a technological glitch now, but I'm assuming you can. Yes. Okay. All right. So a question from Marina. We had problems with SMAP protocol because of the satellite. Will the satellite be passing over my town? Yes, at some point it will. We will have the, when the satellite will be passing over, we'll have the orbit available. Once we get all that finalized and ready for public, we'll get that out. We'll get that out to you. We'll share it on the campaign website as well. We'll have a link to it. But then also we hopefully will, once we do also do the tree height portion of the Globe Observer, we could have it up there like you get notified like when Aqua or the other satellites are overhead. Aqua, Terra, NPP are overhead. You'll be able to take measurements at this time. Marissa has a question. Any way you can include a number of the things that you would like to start working on, or is it up to the webpage? Yeah, it's on the webpage. If you go to the webpage and just, there's a little button here. I'm going to share my screen again so you can see this. I'm going to share on the website, on the Globe website. If you click on Start Taking Measurements, that will take you to, I broke it down into the steps that you can do. Start collecting today. Well, if you actually go to the first part of the website, it says to join the campaign, and there's steps here. I have 10 steps. Last one is just have fun learning all about our planet through Globe, but it tells you exactly what you should do to become part of the campaign and to start taking measurements. So that's just www.globe.gov/web/trees-around-the-around-globe. I didn't make that up. That just came from Globe. I didn't make up that URL, but that's the URL that's at the top of the screen right now. All right, let's go to some more questions here. All right. Valerie does mention you won't be able to directly connect your phone to the satellite, but with the Globe Observer app, you'll be able to get alerts. Yep, I said to her head. Ryan said, so yeah, you'll be able to get alerts as well. Can we locate ICESat 2 by GPS ourselves? I'm assuming yes. If once the orbit patterns are there, if you have a GPS receiver, it might show up. Yeah. Japstreet says, what about the app on which we can get to know about the number of trees, and then we can count the dots? So I'm assuming you're talking about the Collect Earth one that Peter just showed. All right. I see it, Peter's in the posting some comments here. Okay, observation of the observer. You can't put any height measurements yet into the observer because the tree height measurement is not there yet. We are working on that right now. Why can't we use ICESat 2 to measure roots of trees? That's simple answer is because the laser pulses do not penetrate the ground. They hit the surface of the Earth and they bounce back to the satellite. They're not actually penetrating the soil or ground or anything where the trees are. It's just bouncing off the surface. It's bouncing off the leaves, bouncing off the trunk. It's bouncing off, anything that has elevation. So that's why you can't do that. Okay, yeah, and thank you, Valerie. There is a group of working on a visualization system for the ICESat 2 flyovers. It's called Open Altimetry. Yeah, if you check out that Open Altimetry link that Valerie shared in the chat, that's really cool. It shows you some, generated data, some just data that they put in there for ICESat 2, so you can see how it looks on the map. It shows you the actual laser pulses and the photons. All right. Navia, we cannot put the tree height measurements into the Globe Observer because the tree height measurements aren't there yet. It hasn't been released yet. Oh, yeah, there's the Open Altimetry up on the screen now. That's the Open Altimetry, and you can look at the ICESat 2 simulated data. Thanks for popping that up, Adve. It's pretty cool. All right. So can the laser beams be going inside water bodies and measuring certain data? So what we're doing is we're bouncing off the surface, so we're not actually going to be, it's going to be bouncing off the ocean surfaces, off of the bodies of water. And yes, some of that laser light might penetrate into the water, but we're getting that time it takes for it to leave the satellite, hit the surface, and come back again. So we're just looking at elevation. We're not looking at, what the bodies of water are made up of. And you should also know that, you won't be able to see laser pulses bounce off the Earth's surface because it spreads out so much. It's a low-powered laser in the satellite, and as it spreads out, it creates a 17-meter footprint on the planet, but you won't be able to see it on the ground like some of the visualizations show. That's just for an artist way to look at it. Does anybody have any more questions? From Martin said, why is this campaign will take 3 years? So it's a 3-year campaign because we're starting off taking measurements, trees, but so we're doing it so we can look at these trees over time. So students will have the ability to take measurements over time of different trees. And in the future, you know, we're going to have some collaboration with some other campaigns, especially the European Phenology campaign. We're going to be doing some work with them. And we're going to be working with some other campaigns as well, like, you know, tying into the new Mission Mosquito campaign. So we're going to try to connect all these different campaigns to help us better understand our planet. So we're super excited to see that happen. So how is the measurement of trees useful? So looking at tree height, you can look at biomass, you can look at carbon storage, you can look at how our planet, how much carbon dioxide is being pulled out of the atmosphere by trees through photosynthesis, you know, creating oxygen. We can look at many different things. We can look at ecosystems, we can look at habitats, things like that. All right, Peter, do you have any final thoughts here? If you unmute yourself.
All right. Well, thank you guys so much for at least listening to me. Hopefully, you can help us do some of our aerial photo interpretation of different trees around the world, and hopefully that will assist you while you're out doing tree measurements. Our goal is that you use a tool like this as one way of validating what you are collecting on the ground. So watch for a more in-depth tutorial that won't have some of these sound issues associated with it. And so, you know, this is a nice tool that all of us around the world can use to create the same kind of maps with the same kind of information. I will definitely expand on why tree height is important to somebody like me. I study changes over time, and so tree height is one of those that is really important because we can see trees growing, and we can see the vigor. How well are they actually growing, and how might that be affected by something like climate change or the type of weather that we actually have from one year to the next. Also, I study forest fires, and what is usually lost in fire is forests and trees. And so, being able to measure the height of those trees allows us to really understand the effect of the fires as they go through and change the carbon cycle in an area. So, if a tree actually becomes smaller, or it disappears, usually that means that there was a process that happened, a fire process or some disturbance type of process that has removed carbon from that part of the world. Is a really important piece of information to track because that is how we get the oxygen we get. It is how we understand and can live on this planet is through the carbon cycle. Measuring the tree height by itself can give us all, but together with some of the other instruments that NASA has, that means that we can really start to understand the three-dimensional part of Earth. And that's where everybody here who's on this call can really help, because these things can change. And so being able to track is really important for scientists to understand how the world is happening, and importantly, helping us to make data available so that decisions can be made from them. So we're just beginning our mapping, measuring, and monitoring. And so we'll be releasing some other tools. Get to know your globe protocols and go out there collecting some data.
All right, thank you, Peter. All right, see lots of stuff going on in the chat, lots of great stuff, lots of unnecessary stuff. But hey, you know, we're pretty informal here, but we want to get the message across that, you know, this campaign, Trees Around the Globe, we want people to learn exactly how trees are researched in different environments, how people from all walks of life and research are looking at trees to help understand their environmental, you know, their environment better, their local environment, so we can paint this global picture of, you know, why studying trees is vital. So that's why, Peter was showing this Collect Earth today to give you another one of these tools. And I should also mention that, and I'm going to share my screen one more time, on the Globe website, if you go down to what's now a link called the campaign community, you click on that, what you can do is you can see the Collect Earth is there, but we've started to update this resource list below. If your students plan on doing some research projects using tree height and some of the other measurements that are part of the campaign, here are some really great tools here to assist you in that. These are just some tools that you can go and look at satellite data. You can look at, different tools that will help you expand upon the measurements that you're taking with Globe. So everything from that open altimetry site that was shared earlier to the forest observation system, Collect Earth, the GROW app, which is the main app that is being used in the European Phenology campaign for Globe. And then we have some ways that you can look at the NASA data, looking at NASA Worldview. You can look at using something called NASA Earth Data. Then there's GIS geography. So, you know, take time and explore these at your leisure. And a lot of these will really help you out to understand, you know, why we're looking at trees and how what are all the different ways we can look at trees, not just for the sake of them being pretty, but they really serve a purpose in our environment, and they're really vital to basically how our planet functions. So yeah, so that's another really cool thing that we have part of this here. And then there's gonna be some documents, and then feel free to, the teachers here, please feel free to add some blog information, and we have a discussion forum. You can add a blog under the blog section. You can do a discussion forum. Not many on there yet, but you can post anything, and, you know, if you have questions about the campaign, you know, that I can answer, Peter can answer, or some other people, you know, can answer. Share how you're taking your measurements. Share how things are happening on your side of the world, you know, as far as looking at trees. And remember, with this campaign, tree height is our main measurement, but we're also looking at land cover classification. We're looking at carbon cycle, we're looking at green up and green down. So we're looking at all these different protocols to really paint this picture of trees around the globe. So hopefully you'll get a chance to continue taking measurements, or even start taking measurements if that's your situation. So remember, those you know how to contact me, I have my email. You have my email, and you can get a hold of me. If not, you can post it in the discussion forum. So I'm going to stop sharing again, and I will end the recording in approximately 30 seconds. Yep, thank you, Peter. I was just going to answer that about counting individual parks and roadside trees. Yeah. All right. So I'm going to stop recording now, and we will end the meeting. So I'm going to stop in 3, 2, 1.